excuse me, so here is our statement, if P then Q. We set up a truth table, okay? We start by writing down the truth values of P and Q because those are the two statements that we're compounding into the statement if P then Q. So we do this as usual. We've done truth tables before, so I don't have to explain how we list the possible truth values. Okay. Now remember that a conditional is true unless P is true and Q is false. You can't get a false from a true. If something, if the statement if P then Q is true, and if Q is false, then P can't be true. Okay, so we have the condition where the P in the Q statement have the truth values true for the antecedent, false for the consequent. That occurs in this row where we then conclude that in this event the statement is false. In all other events, the statement is regarded as true. And the logic of that is clearly if P and Q are both true, then we can say if P then Q, and that's true. If P is false, then we can't say that this statement is false because anything can follow from a false antecedent. Okay, any consequence can follow from a false antecedent. And then we simply note that the next two rows, the last two rows of the truth table have false values of P, so the statement can't be proven false, so it's regarded as true. So we have true here and here. Okay, now fairly straightforward. Okay, let's take the converse right here, the statement if Q then P. Well, evaluating it by the same rule, the rule being as long as we don't have a true antecedent and a false consequent, the statement is true. Okay, the only place where the antecedent is true and the consequent is false, now the antecedent is Q, so Q has to be true and P false, well that occurs here. Here's the antecedent Q being true, the consequent P being false. This makes the conditional false. In all other cases, the conditional is true. Now we can see from the truth table that these two statements aren't equivalent because they don't have the same truth values. Okay, if P is true and Q is false, this one is true. If P is true and Q is false, this one is false. Okay, clearly when this one is false, this one is true. They're not equivalent. Well, let's move on to the inverse. Now that's the statement if not P then not Q. So again, in setting this up, these two columns would be blank. We wouldn't even have a heading at first. We just go out here somewhere to the right, far enough we hope that we can fill in what we need and write down if not P then not Q, and we have our P and Q truth values. And then we ask ourselves, what do we need in order to evaluate this statement? Well, we need a column for not P and we need a column for not Q. If we have columns for both not P and not Q, then we can just look at those columns and evaluate the statement. Okay, well, we make then a column for not P, and we write down truth values, which are the opposite of the truth values in the P column. And we do the same thing for not Q. Then we just look at these columns. The antecedent is this one, the consequent is this one. We look for cases where the antecedent is true and the consequent is false. Well, right here is the only case where that occurs. In these two cases, the antecedent is false, so we don't have a true false. And in this case, both antecedent and consequent are true, so we, again, don't have the true false. And here's our truth table. Okay. We do the same thing for the contrapositive statement, if not Q, then not P. Okay. We need columns for not Q and not P. And I choose to write the not Q column first and the not P column second, so that I naturally check these in the correct order, in the order consistent, the order in which this is the antecedent, this is the consequent. And I look for the case, or any cases, where the antecedent is true, the consequent is false, and I find that it's in the second row where P is true and Q is false. That makes not Q true, P false, makes the conditional false. In the other three cases, you either have a false antecedent or you have both antecedent and consequent being true, so we have truths in all those. The result that we see here, and I notice I've got this circled because that's our ultimate set of truth values, so let me circle those here and here and here as well. We see that these truth values are the same as these, which confirms what we concluded over here, that the statement and its contrapositive are equivalent. They have the same truth values in all cases. Okay? We also note that we couldn't conclude it from what we did here just because neither of these is equivalent to this or this doesn't mean that these are equivalent to each other. But as we see here, it turns out that they are equivalent to each other. I'm sorry, I'm looking in the wrong place. The inverse and the converse have the same set of truth values. They're true in the same circumstances, they're false in the same circumstances. So we have two pairs of equivalent statements, the statement and its contrapositive, and the inverse and the converse. So, statement and contrapositive are equivalent, converse and inverse are equivalent. Now there's one other comment, but I'll save it for short explanation right after this one.